Back, everyone, for day 2 of DevOpsDays Boston. So my name is Michael, and I will be one of your MCs for today.
I'm Kate, the other MC, also site reliability at Staffy, a startup that does fintech.
All right, so just a couple quick things to go over today. Some repeat stuff if folks are just coming in today. There's a bunch of information on your badge. It's got a layout, it's got a schedule, and it's got the Wi-Fi information, so hopefully that'll be helpful there. So there's some details there on your badge.
And if you haven't already, definitely get a hoodie. We don't want them to end up in Don's basement. So definitely grab a hoodie if you haven't already. And also just friendly reminder, we want to keep masks on at all times. You know, we're really not trying to make this a super spreader, so do your part. Masks when you're not eating or drinking. Food and drink, again, prohibited in here, except for water. So masks should always be on in here, and then only come off when you're eating. And on that note, and on the note of being respectful to everyone around you, friendly reminder again of our code of conduct. We take this really seriously. So just a reminder to be excellent to one another. And if there are issues, grab one of the bus in red. We're really here to help. We're here to respond, and we're here to support you. So just be kind to everyone, and we'll have a great conference.
All right, and I want to give another big thank you to all of our sponsors. They make this event possible, so please go visit our friends, check out, have some awesome conversations with them, and check all that stuff out. So without further ado, I'm going to pass it over to Kate.
All right. So hello to the people online. Quick reminder that we are hybrid this year. So thank you so much for the folks doing the tech, and hello to everyone who's streaming online. Thank you for being a part of the conference virtually. This is really awesome that we can do this both in person and virtual. So hello to everyone online. And without further ado, I'd like to introduce our keynote speaker for the day. Peter Chestnut has decades of experience building web apps, and more recently working on AppSec for Bank of Montreal and a bunch of other really awesome companies. So we're really excited to have him today talking to us about feedback. So give it up for Peter.
Good morning, everyone. I'm very excited to be here, and special shout out to people online. I want to tell you as we get into this that I'm looking for feedback as well. This is the first time giving this talk. And one of the rules of doing the speaking circuit or going out and submitting yourself is you never build the deck until it's accepted. So for any of you speakers out there, you know what I'm talking about. So this is the first time this has been given. This talk, I had this idea about 4 years ago. Super excited to give it to you. I'm hoping the content is everything that I think it is, but the only way for me to know that is to hear from you. So whether you're online or in the room, if you want to tweet about it, if you want to take down some notes, I would love to hear that. So we're about to science it. Again, in the introduction, my name is Peter Chestnut. I'm the CISO of North America at Checkmarx. I am an engineer. 30 years, that's my career, that's my tribe. I still write code even though I don't get paid for it anymore. I still enjoy it. So I do it because it's fun, not because I get paid to do it. I came into AppSec about 16 years ago. I worked for a local company, Veracode in Burlington, and started my AppSec journey. Spent 12 and a half years there building the product, moving from individual contributor to engineering leadership, to evangelism, and really learned a lot in that journey. Took that over to the practitioner side and ran application security for Bank of Montreal, and then decided to come back into the vendor space because what you see as a prospect and a customer is very different than what you see as a vendor and what you're allowed to see when you're having discussions. Checkmarx is an application security company. We help you test, secure, understand the vulnerabilities in your first-party code, your second-party code, your open source, infrastructure as code, containers, anything you can think of around your journey to cloud native, Checkmarx does. So I would love to have a conversation with you about that or anything else in this talk. So let me set the stage here. I have gotten explicit permission from the organizers to give this presentation and give feedback to you if you are ready to hear it. You are now giving me implicit permission because you're all sitting here in the room. You didn't have to be. But I'd like your explicit permission. Do I have your permission to give you some feedback? Excellent. Thank you very much. This is, by the way, one of the things that I'm going to go back over. This is key, putting people in the mindset, giving people that readiness that allows them to say, okay, I'm ready to take it, because it's not necessarily going to be good stuff, or it's not necessarily going to be what you want to hear, but it may be what you need to hear. So let's talk a minute about the things and the places that we get feedback from. We get it in our personal lives, from our friends, from our family. I get it a lot from my spouse. I fall short a lot, and she's ready to point that out to me. My children. In our professional lives, we get it from our peers in the company. We get it from management and leadership. Hopefully not just at that year boundary where we're like, hey, time to give you feedback. But we get it all the time from various places, personally, professionally, and DevOps days, we get it from machines. We have tooling, we have tests, we have boards where we're trying to move stories from stories in to stories out inside of a sprint. There's feedback to be gotten there. Did we successfully make it through the sprint? Did we deliver all of the velocity that we were supposed to this time? What can we learn from that? And if you think about the second way of DevOps, it's about amplifying feedback. So we want to take those opportunities to learn. This is the whole career path that we've been on as builders. The genesis of this story was from my career, I'll call it a career, as a parent and a soccer coach. I coached all three of my girls. They're all grown adults now, out of college, off doing their adulting thing. But for 15 years, from the time they were about 4 until they were almost 19, I had the privilege and opportunity to coach them and coach their teams. Now, if you were standing next to me, I'm kind of and I used to be bigger, but I'm a big guy, deep voice, very confident in what I say and how I say it, to a 5-year-old, to an 8-year-old, to a teenage girl. That can come across as very intimidating. Especially if I'm coming up and saying, hey, that was pretty good, but if you just tried this. In soccer, we talk about technique, we talk about tactics. And there's a distinct difference between the two. Did you do the right thing for the right reason at the right time? I can see things that they can't because they're in the game, and I need to be able to deliver that feedback. I need to say, hey, not bad, let's try this. The way I started every season, and my kids would remind me, hey, by the way, my friends are a little intimidated by you. My motto and my mantra to the team is you don't have to be bad to get better. That's the key to feedback, to delivering it, to receiving it. It's not you're a bad person or you're a terrible player. It's I am investing in you. I am taking time with my expertise to show you something that maybe you don't see that you can use now to become a better person or a better player. And if you think about it, every team is immutable. So even though I had a lot of the same kids, you'd have to remind them. And certainly, as they're growing into their gangly bodies and their mental attitudes through life, you have to do those reminders. So that's the culture that I drove. Okay. Kindness. So I've been listening a lot to Patrick Lencioni. Anyone familiar with his stuff? Yeah, 5 Dysfunctions of a Team, soon to be the 6 Geniuses. I've been listening to his podcast quite a bit lately, and I do a lot of research for these talks. And one of the things that he came out with and talked about is the difference between being kind and being nice. Now, if I am going to put my wife into a particular box, I'm going to say she's nice. That means she doesn't want anyone to feel bad. She's a pleaser. She wants everyone to be happy. Well, telling someone they weren't their best selves or that what they did may have hurt someone is not something my wife likes to do. She feels that is something that's beyond her capabilities, But if we are to help each other be better, we have to be kind and not nice. So Patrick talks about the capital J jerk or the lowercase j jerk. And what he means is, if you are withholding feedback, if I don't come to you and say, that was really, I can't abide that, this is not what this team is about, I need you to change this, can we work on this? If I don't do that, then I am being a capital J jerk to her. I am withholding something that could make her better. Hopefully she wants to be better. And in the moments that I am delivering feedback in a positive and constructive way, I'm being a lowercase j jerk, which is good, which we should encourage each other to do. So think about the difference between being kind and being nice, because one leads to improvement and the other one does not. They also talk about iron sharpens iron. I was discussing with a friend of mine last night at dinner. We were discussing a direct report of his and saying, well, are you delivering this feedback? This is an opportunity for them to get better. This is a blind spot for them. And his response was, yes, I am. But the question is, am I really being direct and honest, or are we just having a pillow fight? Am I softening the message so much that the person can't hear what's actually going on? If I asked them to repeat back what they think they heard from that manager, am I going to get that back? Am I going to get back the fact that maybe they weren't living up to the expectations and changes needed to happen? Not just, well, it was a tough week, okay, next week, maybe. You can't keep pushing that rock down the road. Again, back to soccer. So I used to run the league also for about 7 years. And when they're 4 and 5 years old, everybody gets a trophy. And they get a trophy not because they were great, but because we want to encourage them to come back. We want to give them a reason to say, hey, it's in the struggle. Yes, this stuff is hard. Yes, there are new things for you to learn. Yes, you may not score a goal every time you touch the ball, but we want you to come back. And that is a form of feedback that says, please come back, we value you as a future soccer player. But in our companies, if we do that, what are we telling everyone? So let's say I have a bunch of high performers over here, these 4, amazing. They are off the hook good. And they're on a team, sorry, I'm gonna use you because you're a volunteer. You just volunteered. And maybe this player isn't pulling his weight on the team. But if at the end of the year, he gets the same bonus as they do, what does that tell them? Don't work so hard. You don't have to be good to get your bonus. If I pay him the same, if I give him the same raises and say, hey, I just want everyone to be happy, then he's happy and they're not. So think about what we want for our teams, for our company. We want to be surrounded by people that want to be better and are driving to do that, and we turn this into a meritocracy over time. If you work harder, you get more. That's okay. Not everyone needs to get a trophy. And here's the thing about ourselves. We have blind spots, everyone, myself included. You don't have a realistic self-image. Your team doesn't have a realistic self-image. What you think you're capable of and what you are actually capable of are two different things. There are weaknesses in your approach, in your style, that you need to learn from, and there are probably unknown strengths that you have as well. So there is both positive and negative in this feedback, but again, we learn more from our mistakes. Has anyone seen this before, the Johari window? Okay, I got a couple. The Johari window, this is actually from 1955, if you can believe it. I came across this in that podcast from Patrick, and I said, wow, this is amazing. It really frames what you think about as your blind spot. So we have four panes in the window. We've got our public self, and that's what we know and everybody else knows. We've got stuff that we hide, whether it be personal pain or tragedy or strengths. Maybe we don't want to feel like we're bragging, that we know and other people do not. There's the unknown, which we don't know and neither does anyone else. And then there's our blind spot. What people see of us and how we are seen by the world, and we don't know it. And what our goal should be is to shrink this. You shrink it and grow your public self by asking for feedback or from others to deliver feedback by sharing what they know and opening up what we know about ourselves so we can lean into the things that we're really good at. Change starts with you. And what I mean is, you can't make anyone change, and no one can make you change. Now, there can be threats and negative consequences, etc. But when we get feedback, when we are told we are not good enough, are we listening? Do we want to hear what's being said, or are we just looking for good feedback? So I was at my company for about 9 months, and I was on a call with someone that I respected, and I saw something in what they were doing and how they were doing that I thought they might want to hear. So I went to them and said, can I give you some feedback? I've been watching you for a while. I really respect you. I'd like to share something with you. Now, they said yes. That was my permission. Well, I delivered that feedback, and 6 months later, I hear back directly from them in a very angry phone call about that feedback 6 months ago. They weren't ready to hear it. They weren't ready to change. They did not want the feedback. What they wanted was a pat on the back, great job, love your stuff, you're amazing. Now, the reason I gave the feedback was because I thought they were amazing, but that doesn't mean there wasn't room for improvement. Which brings me to timing. We get out of a meeting, I've just delivered this horrible presentation. I feel terrible right now. I want to punch a wall. Is that the time to ask me if I'm ready for some feedback? So we need to think about the timing. It needs to be in time to make a difference where it's still fresh in our minds, but it can't be raw. So as you consider giving and taking feedback, if someone asks you, would you like some feedback? It's okay to say no. You should expect a no sometimes. And hopefully that's a no, not right now. Please come back, after I've had a chance to have a cup of coffee or whatever. And not a forever. But you can't control that. You can only control your side of receiving. There's a book called Mindset, which I would encourage everyone to read. As soon as I read this book, I bought a copy for all of my kids. I'm like, oh my God, you guys have to read this. Think about how you're perceived and how you perceive others. There are two mindsets. The fixed one, which means, hey, I can do what I can do, and I know what I know, and I'm never going to get any better. And then there's the, I take feedback and I change over time. I am capable of growth. I'm capable of being better. And think about which one you want to be, and moreover, how you're perceived by the world. Because I can tell you from one of my previous companies that I made a mistake. I screwed up in an interaction with someone that worked for me when I was a leader that hurt them. That feedback was never given to me. A year later, I was moved into a different position because it was decided that I couldn't grow. Now, nothing could be further from the truth. Once I heard that, I went to the head of HR, I went to the CEO. I'm like, how did I never hear about this? I mean, I get it was a mistake, but we didn't invest in me for all this time, and now here I am being moved over to this other position, which, by the way, was an awesome position. I'm not complaining, but the fact is, I was seen as having a fixed mindset by my boss. I don't want that. So we need to actively put ourselves out there that we are ready and capable of change. And actually, that brings me to another quick story. This same manager, when I would walk into her office, I would stand up. I'm just used to standing on, I'm on my feet because we're sitting most of the day anyways as an engineer. So I was in her office and kind of standing there. And she shared with me in one of our one-on-ones, when you come into my office, you're kind of tall, kind of intimidating. I'm sitting here, this is really, it doesn't help our relationship. So I thanked her for that feedback because I was not aware of it. And it certainly wasn't what I meant to do. I don't want to go into my boss's office and lord over them. So every time I went to her office, I immediately sat down. I took a chair as quickly as I could. Because I know that what was happening was not helping our relationship and not helping us be professional with each other. So take those things and reinforce them in yourself. Does this person look like they're ready for some feedback? You have to read the room too. So when you're asking someone, when you're saying, can I give you some feedback? If you get this face, you know what? I think I'm going to come back another time. Maybe you can break the tension with a joke. But clearly, if they're not ready to receive it, then you're wasting your time and your effort and an opportunity. So you should make the most of that opportunity. Is the feedback you're giving objective or subjective? Is this measured? Is this like I read it as a 3 or a 5? Or is this my opinion and my feelings? Now, both are legitimate because how I'm perceived by the world is important. So how you feel about what I said or what I did is definitely something I want to know. But think about that as well. And is there a way to turn something that was subjective into something that is objective? Don't ever make your feedback about the worth of the person. Don't make them feel that way. Make it about you. Make it about how their impression was on everyone else, and not necessarily about them as a person, because that's going to lead you down a bad path. Every time you have an interaction with someone, you have an opportunity. You're either making your relationship better or you're tearing it down. So when you are ready to deliver feedback, when you want to have that conversation, when you are inviting someone to give you feedback, yes, please give me this feedback, this is an opportunity for you to do one of those two things. Your reaction in the moment needs to be tempered by what you want the outcome to be. So no matter how hard this feedback may be, and I've gotten some pretty tough feedback over my life, if you don't respond in a way that shows them that you're appreciative, that you're taking this in, and that, yeah, it's hard, boy, woo, that sucks. I'm sorry that I did that, or I'm sorry that it came across that way. That was not my intention. These are the times where you are building your relationships with your peers, with your family, with your children. There's a difference between giving and offering. Again, I keep recycling this thought about permission. Would you like feedback? Not here's the feedback. I'm going to give it to you whether you want it or not. It goes back to that constructive or destructive. By offering the feedback, you give them the opportunity to say, not right now, or no, okay. Or for them to mentally prepare themselves for what they're about to hear. But if you just thrust it upon them, now you're going to get what you get, and it's not going to be a good outcome. As a receiver of feedback, as someone looking for feedback, do you request it? I'm telling you right now, all of you here and online, I want feedback on this presentation. Did it help you? Did you find some things interesting? Were there things that weren't interesting, or that were in the wrong order, or the story didn't make sense, or whatever? I want it. If I'm requesting it, I'm asking for your help, I'm more likely to get it than if I just sit around hoping that someone's going to give it to me. At the bank, I had 5 direct reports, and I asked them constantly for feedback. They were the experts. They were closer to the work than I was. Tell me what I'm doing. Tell me how I can help. Guess what? We are human. We don't always get it right the first time, the second time, the 20th time. The tests don't always pass when we check in our code, not because we're malicious, but because we're people. So, and I point this out to my wife, trying does not equal succeeding. I meant to do it better. I meant to be better in that moment. But I reacted how I reacted because I'm a person. So give each other the space to be wrong, to mess it up again, and to find a way to re-deliver that feedback. There were some peers of mine that we would have signals. If there was like a tick that they would have, we would negotiate before the meeting, some kind of signal. Hey, you're doing that thing again. Without having to draw everyone's attention to it, I could draw their attention to it. So if there are things that can help, again, trying doesn't equal succeeding, and if we can help them on that journey, so much the better. When I went to the bank, I was a builder, I was an engineer. I never came into cybersecurity. I'd learned it through my time in my previous company, and I thought I knew what I was doing, but I made it very clear to the 5 direct reports. You guys have been doing this your entire career. Don't expect me to know everything. Please tell me when I'm wrong. I need to mine for the conflict. I need to know that I need to be better. I need to know where I don't know things. Being vulnerable is the key to getting that feedback. So it's not just requesting it, but it's being vulnerable in those moments. Yeah, that wasn't the best me, or yeah, I kind of got that one wrong. It's okay to be wrong. You're going to be wrong a lot. And if you can embrace that to say, I'm going to learn from this, think about our teams, our feedback loops, and our pipelines. Those are places where the machine gets it wrong, where we've coded something and it gets into production and it falls over. Well, I obviously didn't mean to do that. And then reinforce it. When I get feedback, I try to make a conscious effort. Thank you. Thank you very much for telling me that. I wasn't aware of it. And maybe ask some further questions. Do you have any ideas on how I could get better at this? Or do you have an idea how I couldn't have reacted that way? What could I have done instead? Or what could I have said instead of what I did? So if you're requesting that help, you're more likely to get it, and you're more likely to get a partner in making you better, and not just, hey, I'm going to go now. So if you see good behaviors, so if I've delivered feedback to you, and then I see you take action on it, I should find the time to give you positive feedback. Hey, that was great. That was so much better. That just invites him to invite me back in. Hey, well, could it have been better than that? What else can I do? So this continuous process, this continuous improvement journey, we need to be partners on. All right, so now what do we do about it? I've given you guys all kinds of ideas on good and bad here. How am I doing for time? Excellent. I'm always good at landing the plane. What I'll tell you is this is not easy. It is not fun for me to listen to my wife in the way that I screwed up at a family event or with her or with my teammates. But would I rather her start to ignore me and say, well, I guess that's the way he is. And oftentimes this is what I hear from my wife when we're with some friends and afterwards we're like, geez, I wish they wouldn't do that. And she would say, well, they're just the way they are. I'm like, well, why can't I be that way? Why can't that apply to me? Why can't I just be who I am? That's not fair. But again, that's her being nice versus being kind. She's nice outside to everybody else and she's kind to me. Very kind. Now, I really do appreciate the fact that she points those things out, even though they're hard to hear. I want to be a better self. I want to be a better person, a better father, a better husband, a better coworker. But it's not easy. It's not easy to open yourself up. It's not easy to get that feedback that, yeah, not so much. But the fact that you're being delivered that feedback means you still have a chance. There's a chance to get better. There's a chance to improve. You have to have the right culture at your company. And this is true, like if we're talking about DevOps, that agile transformation. We're doing things fast. Guess what? Sometimes things get screwed up. Now, if we can recover fast, that's great. But does it turn into a witch hunt after? Prog down, oh boy, who's responsible? Who am I firing today? Or is it a learning opportunity? And if we don't have that culture between and amongst each other, with our teams, with our leadership, with operations, then it's not a very constructive environment. And we're going to try to duck and hide from these things instead of embracing them as, how could we be better in this situation? How could we have found it earlier? How could we have pulled the ending cord, maybe with some automated tests? We have to be accountable for our own behaviors, and back to that nice versus kind, we have to hold each other accountable. That's what is the key here. If people aren't holding me accountable because I'm intimidating or they're afraid of me or my position or whatever, then I'm never going to get better. So I want to hold you accountable, and I want you to hold me accountable for our team, for our family, for our relationships. And you got to build it on trust. If I can't trust why you're telling me that I messed up, or maybe even the context. So think about where you deliver this feedback. Are you delivering it in a meeting and making someone feel about that small? Are you trying to build yourself up? Or is that the perception? Maybe that wasn't the intent, and again, there's feedback there as well. If you're not in a trusting relationship, in a trusting environment where I can say something to you and you're not saying, why did he say that? What's he trying to get away with? Is he trying to make me look smaller so he can be bigger? So you have to have that mutual trust, or else this feedback stuff doesn't work. You're always looking over your shoulder. You're always wondering who else heard that, who else saw that. And that's not where you want to be. Back to the receiving part, you have to be mentally prepared. I got to tell you, this is a really hard path. You're going to hear some things that, oh boy, I wish I never did that. And sometimes you're even consciously or subconsciously aware of it. Oh, that was a mistake. And then you get that reflected back to you from somebody else. If you care about that person and you care about that relationship, then you're going to want to hear those things, because you don't want to destroy that value that could be there. Which brings me to the feedback of receiving or giving. Why are you giving this feedback now or in this way? Are you venting? Are you pissed off? Are you angry with the person? Angry with the situation? How do you react when it's given to you? Are you defensive? Do you blow up? If you're the boss and they work for you, do you throw them out of your office? Well, what message did you just deliver? Again, the reaction is important. How we react to that feedback is critical to ongoing feedback. So if you're serious about getting better, then you need to be serious about tempering your reaction. Count to 10 if you have to. You can share with them that this is hard. It's okay, they know. They're not unaware. And by the way, I would also thank them for being brave enough to come to me with it. Boy, that was some tough stuff. That must have taken you a little while to bring up the courage to come in here and tell me this. Thank you very much. This is the way we build ourselves and build others. So that gratitude is super, super important. Again, maybe you have to fake it till you make it. Maybe some of it you're not really going to be thankful for. I certainly haven't been thankful for all of the feedback I've gotten, not in the moment anyways. But if you want your perception to be of someone that is worthy of that friendship, worthy of those teammates, worthy of that team, of that company, then reciprocate on the honesty, reciprocate on the courage that they've shown by delivering this feedback to you. So, how good do you want to be? Think about the gaps, and some of them you don't know. Again, we go back to that Johari window. There are things that we don't know that other people do. I'd like to know what those things are. I'd like to mine that to be better, so that way I can live a better life and feel better about myself. So the question is, do you want to go on that journey as well? Think about the team that you're on. As a leader, it is hard to coach someone up or coach someone out. So, but I know that I'm risking the rest of the team. I'm risking their performance, their happiness. These are the people I really want. I'd like to keep this person, but they need to change. So don't risk one for the other. This isn't a friendship. It can be, but not in that moment. If you're a manager, you have to manage your teams up. I want their performance to be up for the good of the company, for the good of the stock price, etc. And as peers, we need to hold each other accountable to strengthen our team, because I want to be on a strong team. I want to be on the winning team. Reframe the way that you see those things. So go back to some feedback that you've gotten, to a time where you weren't your best self, to a time where you really messed up. And look at that and reframe it in a way that says, hey, you know what? To build muscle, I need to break muscle. If you are trying to bulk up, you're actually tearing the muscle. So any opportunities, any failures that you've had have made you who you are today. So while in the moment you may say, oh, Christ almighty, that sucked. You can go back to that and reframe it to say, you know what? I don't do that anymore. I don't make that mistake anymore, and I'm proud of the effort that it took to get there. Best time to plant a tree? 10 years ago. What's the second best time to plant a tree? Today. So as you think about yourself, your teams, your company, your family, make the decision, plant the tree today to be better, to deliver feedback, to receive feedback, to request feedback, because that is your path to get better. So, final ask for help. If you found that there were parts of this that were weak, I would love to hear how I can improve it. Again, it's the first time. After the third or fourth time, this will probably be pretty good. I hope it was impactful to you. I hope that it shared some good ideas and some good direction. My name is Peter Chestnut. I'm the CISO of North America at Checkmarks, and I thank you for your time and attention.
All right. Thank you so much. Next up, we've got Gad Salner talking about how to scale a unicorn building engineering team and how to stay sane. Just a quick note, too. Us as DevOpsDays Boston organizers would love to hear feedback from everyone, and we're incrementally trying to always make the conference better and have everyone have a better time each year. So please, if you see someone in a red shirt and you have some feedback, just reach out to us and have a conversation about that. But yeah, without further ado, I wanted to introduce Gad Salner to the stage.
Hi, everyone. Oh, there's some people up. Can you hear me, everyone? Cool. Didn't see the balcony out there. So one moment. Cool. Hi, my name is Gad Salner. I'm from Israel. I'm a group manager at a fintech startup company called Milio. And today we're going to talk about scaling engineering teams and how we scaled from 1 to 40 engineers and what we did to achieve that. But usually when I come into a room full of people, I'm behaving very nicely. I introduce myself and I said, hi, my name is Gad. And then people in the US probably thinking this is his real name. Yes, my name is Gad. So we don't have time to introduce everyone. So what we're going to do, and believe me, it's more awkward for me than for you. So I'm going to count to 3, and maybe you can all just say your names out loud. Maybe I'll catch up a few names. Okay, believe me, it's more embarrassing for me, but let's give it a try. So on the count to 3, just say your name out loud. 1, 2, 3. Hi, Paul. Nice to meet you. So today we're going to talk about engineering teams and how we're going to scale them. And how we're going to do it with the right vision, asking ourselves the right questions, researching it, planning, analyzing the gaps between where we are and where we want to be. and then searching for the right tools, and even more importantly, creating the right tools to achieve that. So, one moment. So I'm Gal Salner, from Israel, 38 years old, father of two. In the past 20 years, I've been in the Israeli tech scene, and in the past 2 weeks, I've been in the artificial intelligence generated arts. It's going to be throughout the entire presentation, so bear with me. What I did in the past 20 years is being a manager, engineer, engineer, manager, engineer, manager until the last two startups that I worked in. One is very small, you know, as WeWork, where I was one of the first engineers, and the other one is Milio, where I'm currently a group manager. And another project that I'm running called Kaduregel Shefel, which is a documentary project celebrating Israel's diverse cultures through amateur soccer. For example, these photos are from the Israeli desert and the Sea of Galilee. And this one is one of my favorite photos. And these exhibitions and videos will be presented around the world. And I'm very proud of this project because it gave me a lot of tools as a manager to communicate, to plan, and it also led me to the understanding that dream big and plan accordingly. And this is something that I used immensely throughout my tech career. And this number that you see now on the screen is, according to Why Decision Failed book, is the increased chance of having your project successful if you plan and find more alternatives other than two. And where we started as a company, and we're going to talk about it in a few moments, we had a lot of challenges, and let me visualize it for you with a friend of mine, which is Dima. This is Dima. This was the first engineer that I worked with in Milio, and I wish he was with us today. I mean, he's alive, sorry. Dima is very much alive, don't get me wrong, sorry, Dima. I talked to him yesterday, but basically we're going to talk about the several phases that we had in Milio. The first one, when I started at April 2020, as you all can recall, it was not a very good day to start a new job. Beginning of the apocalypse, as I remember it. And the second phase is when we started to assess damage assessment and understand and started to hire people. And then another phase, wow, that's a lot of Dimas on screen, I see, okay. And the third phase is when we scaled up to 40 and going forward what we planned accordingly. So let's talk about day one when I started, and I signed up for this startup company a couple of months before everything closed in. And the first period, like 2 months that I didn't see anyone, just made me realize that how people matter. This is something that as a manager, I always have been a people manager, but when you started to understand that basically when we work remote and there is no office, then there isn't any difference between like the large companies with the brand new offices and cool PlayStation rooms and pools and everything. And basically when you strip that down, you just have and you need to rely on people, because that's the biggest resource that any, I can say company, but any group of people and any project has. It's the people, and this helped me realize, and going forward, this is something that led me to the understanding that we need to double down on that on any aspect of the choices that we need to do. So after a couple of months, we met for the first time, and we started to hire a few people, some of my good friends and colleagues from past works. And we stopped it was the first time that we stopped and met together, and we started to plan ahead. This is the first time that we started to think of, in a very abstract and high-level way, what is a team? What makes a good team win? What does make a good company a winning company? And we didn't want just to think of patch things up, and we didn't want just to fix a flow. We started to think of a more holistic approach, because we understood that we have a chance to create something big. This company was planned to scale very quickly. We knew that we were going to hire many people in the upcoming months. We didn't know how much, but we didn't know that we are starting to create a culture. So we stopped, and this was the first time, and you'll see that it's going to repeat itself. This was the first time, actually, that we stopped and asked ourselves several questions. So the first question was, okay, so the first domain is a team, right? What does make a good team a winning team? Like, how do you take a bunch of individuals and with different motivations, different aspirations, different anything, because all people are different, but how do you make them to one cohesive communicating team? And the second domain was delivery. I mean, once you have a good communicating, cohesive people working together, how do you make sure that you have the right processes to make them deliver the best way? And once you have a good team delivering well, how do you keep a growth mindset and making sure that it's still working together? So we started to break down into different parameters for each. For example, for team, we started to think of, okay, so team needs to be cohesive, communication, every single person in the team should feel that it has an impact, should be feeling engaged in what he's doing. And the second part is delivery. How do we make sure that everything is transparent, the work we're having a good velocity? And the third part is growth. How do you keep a growth mindset? How do you make sure that people are still growing together? They want to stay in the company. They want to make sure that the team is even more cohesive once you deliver something. And we started to think about it as a feed-forward cycle, that each and every step is relying on the step before. Like, we meant a very holistic approach, that we didn't want only to double down on delivery and forgetting about the people. We didn't want to double down on people and forget about their growth mindset. So we started to think about it as a feed-forward cycle, and this is something that we kept in mind throughout our phases in the company. Like, any phase had their own feed-forward cycle. And later on these domains and parameters, we started to do a SWOT analysis, and for those who don't know what it is, it's strengths, mapping the strengths, the weaknesses, the opportunities, and the threats of the current situation. Again, based on the feed-forward cycle that I just mentioned. And for example, our SWOT analysis was actually very same, I guess, for many companies at the same stage during remote and during Corona, which is the strengths was, okay, we were a good bunch of people. It was a good company with great opportunities. The weaknesses was, again, on one hand, we have a good small team, but a small team means that if one of us is not feeling motivated or one of us is leaving, then we have a problem because we're very small. And again, the opportunities was that we're going to hire a lot of people, the company is growing, and the threats were hypergrowth. This is something that is threatening each and every organization. I mean, how do you make sure that the 10th or 15th person feels at home like the first people or the second person? And how do you communicate well? And the most frightening threat was, of course, the pandemic, because everyone was feeling alone, everyone has its own concerns in his personal life. How do you keep communicating through remote, because we weren't used to it? And we created action items specific based on the SWOT analysis and on the feed-forward cycle and its parameters, which are, again, team and delivery and growth. And basically, I have an entire present talk about working in remote and how we figured it out. But just a few examples. For example, for team, we worked on remote, yes, but we did 2 sync meetings a day. The second meeting was with different random person in the company to get to meet each other. When we got a chance, we did our one-on-one meetings at parks. We created and doubled down on communication channels to make sure everyone's not left behind. Regarding delivery, each feature we made a strict rule that each feature has to work with 2 engineers, one more senior, one less senior, to make sure that no one is working alone and everyone is learning from each other. The senior one is learning how to mentor others, and the junior, less senior, is learning from the senior. We had a very strict checklist of dev cycle, just to make sure that in the office, of course, you can turn around and ask your colleague about oh, did I forget something? But when you're at home, you're not. And regarding growth, and again, this is just small examples, but the important thing is the holistic approach that we thought of. We didn't miss any detail. We signed everyone up for different resources to read. We shared what we learned. We had like live demos online, which was much easier than the demos that we have nowadays when everyone's back in the office. And it worked well. It worked perfectly well because we still grew. We had like a good cohesive team that delivered well, and the company really enjoyed it because we grew, and both in number of people and also in the value of the company and its products. So a year passed, and we were almost 20 people, and no more COVID restrictions. And now at that point, we started to think again, okay, we're 20 people. Now what? What we're going to be in 6 months from now? Where we're going to be a year from now? We're going to be 50 that's people. We're going to double ourselves. So again, we paused for a second because we wanted to understand what is going to be like on different aspects of our engineering domains, both technical and cultural aspects, when we are 50 people. How is going to be the onboarding process when we're 30? How is going to be the dev experience when we are 30 people? Because it's a completely different challenges that we need to face, and we need to address them now. So what we did is we started to, you're late, Dima. What we did is we started to map the entire engineering domains that matter to us, that were a challenge for us. Most of you will probably see it and say, yeah, that's our same challenges. But as you can see, some of them are more technical, like testing and monitoring, and some of them are some of them are more cultural aspects, like onboarding, engagement, knowledge sharing, and growth. And we thought of it like on several axes. And for example, what if our company looked like this? What if our testing was very good, our onboarding was great, but our dev experience wasn't that good? What if our velocity was great, but our engineering engagement was bad and our onboarding was even worse? What does it mean that now new people come and they'll have like a very bad onboarding experience, they'll take time to ramp up? So we try to think of several approaches that will help us on board and make sure that the next 30, 40 people will join the company in a great way. So one approach is the stale. I mean, we all have our own a very busy CTO that has something that he needs to deliver, and product managers that are very, very pushy. So one approach is do nothing. I mean, we have enough work. What will happen then is all of our engineering domains will get even worse. People will probably leave because people crave for engineering challenges. People crave for growth opportunities. So of course, this is something that we didn't even think about. Another approach is top-down. I mean, we as managers, we can define, we know, of course, we know what's best for everyone. We will tell people what testing should be like. We'll tell people how onboarding should be like. But we passed on that as well because we understood that if we get this approach, first of all, we as managers, we don't have the capacity to think about all the details we want to reach in all these engineering domains, right? Because we always think of a very holistic approach, a very detailed approach, a very high resolution approach, and we want to do it across all domains because we understood that a year from now, when we are 50 people, we need everything to be as best as we can. And another thing that about top-down approach is we're losing the accountability and we don't have the buy-in of the engineers. Because the engineers say, okay, they decided for me how testing should be, so I just need to deliver what they tell me. And okay, so I'll start to look maybe for another place and I can make an impact. Another approach is a domain-specific approach. I mean, we don't have time for everything. We need to make sure our testing is better, so let's make sure we have testing great. And what we chose to do is engineering-led approach, which means that we'll give the engineers themselves the opportunity to lead every aspect of what they're interested about, and we'll pair them with managers. And we called it the group framework game plan, and the steps are as follows, and I'm going to run through it. Again, first of all, we need to analyze where we want to be and where are we now in the gaps between. And we found out these are the domains that we wanted to double down on. The next step was to assign it to people. And now this was the part that I was very afraid of. We made like one-pagers with current status, problem statement, and goals for each and every one of these domains, and we actually printed them and gave them to the engineers. And I was afraid that engineers are very cynical, and they'd say, okay, what's that? I don't know if I can use that word, so I won't. And we handed out to them, and we found out that they were very excited because suddenly they had chance to make impact in domains that they didn't even know that they can lead. Some people are more cultural, interested in culture, so suddenly they have an opportunity. Some people are very into testing. So we started to pair them up with different managers, not their own, but managers from different teams, just to make sure that they are even more cohesive as a group. And then we send them out to research in what they do in the company. We made it, and we make it mandatory for them to reach out to different companies because networking is very important, and you don't have this skill on the day-to-day basis. And we ask them to study. We ask them to buy books. We ask them to sign up for courses, and they did. And for each and every one of these task forces, we ask them to make a plan. Like, what's the North Star? What's the timeline? What's the OKRs that we're going to measure it on? And probably you need resources, right? You'll need time, you'll need maybe money to sign up for courses or different tools. And suddenly different engineers have the chance to plan, to have a holistic plan and think thoroughly about what they're passionate about. And once they did all that, we asked them to share with the entire group. And suddenly people from that double down on testing share their learnings with the entire group. And the task force of the onboarding shared their learnings with the entire group. And everyone learned from the different experiences of different task forces. And then you need to deliver, right? You need to have the OKRs, you have the timeline, so you can be measured on, and you need to double down on that. And this way, we made sure that the entire group is growing, with the engineers growing as well. This led to a very good situation that suddenly, when we were 40 engineers, as we are today, we had the privilege to think forward again, because we had a very good group. People started to join because they knew it's a good growth opportunity and a good company to join. And then we started to map again what we're going to be when we're 80 engineers. So again, we started to analyze the situation, and we understood that task forces are working very well, but they don't communicate well with each other. We're not fully optimized with having the different outputs and inputs of different task forces that can impact different task forces. And what do I mean by that? For example, let's take testing. Testing influences different aspects and different engineering domains. It influences the onboarding, because if we want the testing culture to be very good, we need to be as part of the onboarding. And if we want people to test and do it with like joy, and the dev experience should be affected, and maybe the dev cycle should be adapted as well. But testing is also influenced by different task forces, for example, monitoring. So what we did is we thought of ways to address that, and the two ways we thought is, one, the tech leadership framework. Like we had started to have tech leads for each team. We should utilize them. We should make sure that they work as a team. We have 4 tech leads, 1 principal engineer, and they should work as a team. They have their own KPIs, they should have their own communication channels, and they should work together, because this is the way you can spread the knowledge and make sure everyone learns and everyone is sharing the data. And the second one is data-driven task forces. Let's take testing, for example. Testing is influenced by different domains. For example, testing is based on the code base itself, on the sanity tests, on different research and incidents. And the output of the testing is, as I mentioned before, we should make impact on onboarding, on dev cycle, on developer experience. And the way we're going to do that is by the tech leadership framework. And if you see that nice animation, is all these different task forces are impacting everyone. It's impacting different task forces and different aspects of engineering. And once we make sure that the tech leadership and the tech leaders are communicating and being ambassadors for each and every one of these task forces, we can make sure that their knowledge of each task force is being passed throughout any one of the squads, because we're not 10 engineers anymore, we're not 15, we're 50, we're going to be 80. And we'll only now, from now, we're starting to think forward. And basically, what's next? What's next, we don't know yet, because we're currently 40 engineers. Again, we're aiming for the next 40. But what I'm sure, and this is something that this is an advice I can give you. It doesn't matter if it's your pet project, your culture project, your team. It doesn't matter if you're an engineer now or manager now, or you're thinking about your next career path. It's dream big and plan accordingly. Like every time you face a new challenge, or any time you think of a new project that you're going to step into, pause for a minute, analyze the situation, have a vision, have a good vision, map the gaps between where you are and where you want to be, and find the right tools to act upon it. So thank you very much, everyone. And it's been a pleasure to be in Boston and this conference. Thank you.
All right. So we're going to take a quick break here so folks can get some coffee, go talk to some of the sponsors, and generally just hang out and have a snack. We'll be back at 11:10. All right. Thanks.
All right. Hopefully we get some folks meandering back in here for the next talk in the next couple of minutes. Anyway, next up is Adarsh Shah. He's the founder and CEO of Z Lifecycle. He's also involved in DevOps Days NYC by way of organizing, as well as the conference, as well as the meetup. So he knows what I'm going through right now. Anyway, on that note, give it up for Adarsh.
Hey folks, thank you for being here. How's everyone doing? How are the sessions? How are the open spaces? Yeah, good to be back in person. This is my first in-person talk, so I'm really excited. I hope you all had a good time. So yeah, today, my name is Adarsh Shah. Today we are going to talk about something new as code. We have so many things as code. Today it'll be environment as code. This talk is basically based on my and my team's experience, kind of working with infrastructure as code and cloud native tools over the years, and what are the various challenges we have seen implementing or building a platform or automation for various companies, from enterprises to startups. So some of what you hear about environment as code is kind of new, and I would love to hear what you all think. If you have any feedback, if you want to discuss further, I'll be around. So yeah, let's get started. All right, so I'm going to go through a couple of terminologies just to make sure that when I say them, you understand what I mean. First one is components. So when I say components, what I mean is a logical grouping of one or more infrastructure resources or applications. So one of the examples is networking. If you want networking, you want your VPCs, your subnets, your internet gateways, and route tables. So as a group, I call it components. And then when we say environment here, that's the logical grouping of multiple components. So it could be networking, your EKS cluster, your databases, your Kubernetes apps, all of that, whatever is a meaningful grouping for you, that'll be environment. So we all know what infrastructure as code is. It enables teams to deliver infrastructure and thereby software running on it rapidly and reliably. And here's how I see an evolution of when you start using infrastructure as code. You probably are one or two developers who do some POC. They kind of write some monolith ISE that provisions your networking, your EKS, what have you, and you test it out locally on your laptop. Things work good, and then people love it. Other developers want to use it, or they want to run it. And then you start kind of feeling the pain of, there are so many different components, right? I want to break my ISE into multiple separate components so that it's not a one monolith ISE with a massive state file if you're using Terraform. And then if you have Helm charts for your apps, same thing. You want to break them into smaller pieces. So yeah, like here, as you see, you have multiple Terraform components, and then you have your apps with Helm charts. So this talk is for folks who have already started ISE, or they are looking to do so, or at least a little bit advanced, where they are looking to at least break those monolith ISE into smaller components. And then here's how I see an ISE execution evolution, right? So again, you start by running stuff on your machine, and then eventually you look into writing your ISE pipelines, or using GitOps way to kind of provision in a shared environment, right? So your laptop might have certain dependencies or certain version of Terraform, but you want to run it in a common shared environment like a pipeline where you have more reliable setup. So again, when I say environment, this is an example of an environment where you have a bunch of different components put together and that might be a production environment where you have networking and EKS and database and SageMaker and all that stuff. So what are the current options if you want to provision an environment like I just showed? Again, you can either write a monolith ISE, create a pipeline, run it. Works well if you have a really simple setup. Or you hand roll all these pipelines. And when I say hand roll, so let's say you are using Circle CI and you're doing pipeline as code, you write all that code, and I have seen that code get really messy. Basically, we at one point, one place, we had like 1,000-line code to provision 4 different environments, and then logic to tear down where you want to run things in, different order. You want to start at the leaf node, destroy them, and go up the chain. And all those managing complex dependencies and secrets and all that, those pipelines become really complex. So those are the 2 options currently, is what how I see it. And they are not scalable. It's once you start getting into more complex environments, it just becomes very difficult to manage. So what are the other challenges when you scale ISE? Replicating environment is a pain. Let's say I want a performance environment where I can run my performance tests. And it should look exactly like production, but a separate environment. Again, you have to go through, copy your ISE code and write pipeline or change pipelines. It's a lot of work. You can't visualize or understand environments. How do they look? Sure, you have everything as code. You can go look at your Terraform or Helm code. But again, there are so many various pieces you need to look at and put together to understand how they look. Drift detection. I mean, yes, Terraform, when you run Terraform, it tells you if stuff is drifted. But how do you know that my production, if you want to answer a question like, is my production environment exactly how I want it? There's no easy answer. You have to look at a bunch of things. You might have to run Terraform multiple times. Now, for apps, if you have Kubernetes apps, sure, Kubernetes does that for you and it reconciles your changes. But for your infrastructure, you don't get that same kind of drift detection or reconciliation, basically. And the last one is, and someone actually mentioned in one of the open spaces, is it's not straightforward to promote changes, right? You can do GitOps, you can have all your Terraform and Helm charts in Git, but there are so many different places you have to look at. And if you're promoting changes across environment, there's no single pane of glass to kind of see what has changed and how those changes look. So these are some of the other challenges we have seen while scaling ISE. So what is this environment as code, right? What the heck it is? So here's how we see environment as code. It's a declarative layer on top of all the other cloud native tooling, right? So you have your ISE, Terraform, and Pulumis of the world, and then you have Helm charts and customizers and serverless apps and all that stuff. What we are saying is we need another abstraction layer that kind of puts these various components together and builds something meaningful. And it is declarative. Currently, people do kind of define this how to run in pipeline. Pipeline code is not declarative. Environment as code is. And when I say declarative, you say what you want, and the tool just makes it happen, right? You get that with Terraform and with Kubernetes, but you don't get that with your pipeline code. So, yeah. And then, yeah, obviously, it all gets provisioned or deployed on your cloud provider or Kubernetes cluster. So, yeah, here's another way of looking, right? So again, a top abstraction layer, which has, environment as code, and then you have a bunch of your cloud native tooling that comes under that, and then you have your cloud providers and platforms under that. So yeah, here's another way of looking at it with taking Lego as an example. So on the left, you can see that how I see infrastructure as code is, especially for complex environments, is it automates various Lego pieces, right? So your networking, your EKS, various infrastructure resources and components. What environment as code is, it allows you to connect those various Lego pieces and build something meaningful, a Lego toy, which is your environment. And that Lego toy will be different for everyone, right? Your environment might look different than someone else's. So yeah, that's what kind of, if you look at it as a Lego analogy. So here's a definition I'm going to quickly read, but actually focus on a few different things. Again, abstraction over cloud-native tooling. It's declarative, so you just define what you want, and then the tooling makes it happen. And then, there is a control plane involved, which we'll look into. It's kind of based on the same concept as Kubernetes has a control plane that manages your apps running on Kubernetes. Similarly, for managing your environment, kind of having a control plane. It kind of does things like drift detection and other things. So now let's dive deeper into that diagram that I showed, and this has the control plane part as well. So again, you have your declarative environment as code. You have it in your source control, and let's say you're provisioning an environment. You have a control plane. Again, it could be a Kubernetes operator or something running on Kubernetes. And it manages something that we are calling environment state, similar to what Terraform manages Terraform state. What that manages is all your various dependencies. So run the networking first, and then kind of run EKS and Postgres because you need networking before you get those. And then once you get your Kubernetes cluster, kind of deploy your applications, right? Your Helm charts, run those. So yeah, it kind of manages those dependencies, what the status, if something fails, let's say EKS fails for some reason, it knows that networking was provisioned, EKS wasn't, and then when you rerun it or reconcile, it kind of keeps, the control plane actually does that. It detects any drift, it kind of does that for you. So yeah, that's the provisioning workflow. If you want to tear down, right, again, you don't have to write all that logic. You can just, in your environment as code, and I'll show example format, you can say tear down true, and the control plane knows what to do. It'll start kind of destroying stuff at the bottom, so destroy all your applications in Kubernetes cluster, then destroy your EKS and Postgres and networking, especially if you have ephemeral environments where you want to spin up stuff at 9 o'clock in the morning, and when you're going home at 6 o'clock, you can bring that whole thing down. It is a lot, it's very complex today with existing tooling to achieve something like that, because you have to write a lot of logic. With environment as code, it's pretty easy. So what are the various attributes of environment as code? So yeah, here's an example of our format of environment as code. Again, when I say our format, it honestly could be anything that describes your environment. And as you can see in this example here, what you will see is we have various components. You have some information at the top. By the way, this is custom resource definition in Kubernetes. That's what we use. And then you have team name, environment name. You see that tear down false flag and stuff like that. But if we focus on that highlighted portion, it says, give me EKS. Type is Terraform. I want to use Terraform. And this component depends on networking. And here's my source. Here's my Terraform module or my Terraform code. I want to use the VPC ID that actually was provisioned in my networking component. And then here's my variable files, right? So it kind of provides you the data for that component. Now, the other example here is once you get EKS, I want to actually use Helm for all my Kubernetes apps. So in that case, you specify type Helm, and then again, it depends on EKS. You specify where your Helm charts are, and then boom, you basically should, this definition should be what you need. Once you define this, push it, the system kind of processes it and kind of gives you that environment that you want. And then you see that flag tear down false. If you do that tear down true and push it, it should bring down the whole system. So yeah, another attribute is it enables or encourages actually teams to have this loose coupling, right? Again, you can write a monolith ISC, but by having this capability, It encourages people to have loose coupling, have smaller components that are basically could also be owned by different teams. So let's say for bigger orgs, if you have a networking team, they might own the networking layer and might write the Terraform for networking versus there's another, like app devs could deploy the Helm, write the Helm charts and deploy stuff. Again, it manages state for entire environment. So for example, what operation last happened, again, it's kind of similar to how TF state is, but basically it has the operation that happened last and what's the status, it is success or fail, and it kind of manages that at an entire environment level, and then also manages at various component level so that you know, if you want to know whether my environment provisioning was successful, you can just look at that and kind of get that status. So yeah, idempotency and immutability, a couple of attributes that are core to infrastructure as code. Why not get that for an entire environment, right? So, and for those who don't understand, I'm going to kind of explain what that means here. So on the left, you see that you define your code. You say, I want 3 VMs. In non-idempotent code, when you run that same code second time, it actually gives you 3 new VMs because it doesn't know what the current state is. Every time you run, it'll just give 3 VMs, right? And that's not what you want. You want 3 VMs. So in case of idempotent code, which is what Terraform and Pulumi and those tools do, you specify what you want. It gives you those VMs. If you reapply the same change, it knows that you already have the VM, so it's not going to provision it, so it gives you the expected 3 VMs. Now, what I'm talking about here, and this already happens with ISE tools, what I'm talking about taking up to that whole environment, right? So if I want to answer a question, do I have what I declared in my definition for my entire environment? With pipeline code, you cannot do it today because, again, those various pieces, the pipeline code is not declarative. Another, immutable infrastructure, right? So what I mean by immutable, so if it's a mutable infrastructure, you basically make changes. And when you apply those changes, so you see that it's V1, version 1 of your infrastructure or apps. And then if you apply that change, you apply and deploy those V2 version on the same infrastructure. On the immutable side of things, though, if you make a change and you want to provision 3 VMs with version 2 of your code or infrastructure, it'll provision brand new VMs, right? So you don't keep long-lived infrastructure because you can have drift detection and over a period of time, things drift and stuff like that. So yeah, and then you basically route your traffic to the new VMs that were provisioned, and you get rid of the old one. So in case of immutable infrastructure, your infrastructure is not long-lived, which is a very key thing to achieve. If you achieve that, that's pretty good because you avoid a bunch of issues if someone made manual changes and stuff like that. Another attribute is visualizing and understanding environment. So now, this is an example from our product, but the key point here is you have all this information. If you think about the state file that was there, that tells you what's the status of your entire environment, individual components. You can even have other things like cost calculations and other things, and then kind of show all that information and visualize that in a way that makes sense. If I want to know how my environment looks like, how my prod environments, I can go to that one place and I can see the status, what happened, what changes. You can have auditing and other things built on top of that, but this gives you a visual of what an environment looks like. Another thing is drift detection. So again, it happens if you run Terraform today or Pulumi, it tells you there is a drift if there is one. But what I'm talking about here is, can you answer a question, is production is same as what I defined in my configuration? And it's very difficult to answer that question. And this is kind of same as what Kubernetes controllers do, right? They have this control loop, and if your apps go out of sync, the Kubernetes controller will bring them back to the desired state. So what I'm talking about here is taking up notch and kind of saying, can the entire environment be done that way? Now, you will see at the bottom, I say preferably with approval step that shows the plan. So for example, if you have Terraform and someone changed something manually or an indirect change in your cloud provider, you don't want to just revert back changes to the desired state if it is infrastructure, because that might involve destroying a resource, because sometimes changing stuff, preferably you should have a plan. You see the plan, you see that, oh, something's changing, maybe destroying and creating a new one, but you know what changes are happening, and then you might need an approval step before you bring that back to desired state. Other changes, other kind of attributes is comparing and promoting changes across environments. So as I mentioned, and in that definition, you see it's all file-based. You define what an environment looks like. You push it to your source control. You can compare those changes using source control, or you can use other tools to make it easier to compare. And then also promotion is easier, because now you're not looking at 10 different files at 10 different places, but you're looking at one abstraction layer at the top that will tell you what version of networking is deployed and what version of EKS or your apps are deployed. And that can act as a place where you can say, now I want to promote from dev to QA, the same version I have in dev. I can look at the dev config at one place and say, oh, we actually updated the EKS version. And here's why the version of new module is 1.2. And you make that same change in your QA and then to production. So it makes it easier to promote changes as well. And then, yeah, you can use GitOps, but not just for your individual components, but for an entire environment. So what I mean by that is, let's look at this example. So yeah, on the left, you kind of push your ISE code. You can even create a pull request, go through the GitOps process. You can run your maybe plan or something that shows you similar to what Atlantis and other tools do, but this will kind of do it at an entire environment level. Once you do that, someone looks at it, you can run your tests maybe here, and it could be anything like TerraTest or one of those frameworks, or you can also for your Helm charts there is testing, so you can do some of that testing. Once that happens, one of your teammates looks at the PR, everything looks good, they approve it, they merge it, and once that's merged, it kind of control plane takes over. So control plane is observing your Git repo, let's say, similar to what kind of Argo CD does for your Kubernetes apps today. It observes it, it picks up the change, and it says reconcile the change, which will basically give you what you want, right? So all of this kind of being in a GitOps way. So you get auditing, you get someone to review and approve the changes if you want. And if you have teardown, let's say you want to tear down the whole environment because you want ephemeral environments, it'll be the similar flow. You make a change, in this case, maybe one single line of change that says tear down true, and then the whole thing will happen and you go through the process. So this way you get all the benefits of GitOps as well at an entire environment level. So yeah, that's the talk. Basically, something I would like to hear from you all, does it make sense? Have you had these challenges? If you're scaling your ISE, did you actually face these challenges where you had to write a lot of pipeline code or a bunch of other scripts that actually ran those individual pieces? Any other issues? The slides and some other details are at that bit.ly link, or you can even actually scan that barcode and it will take you to the page that has all the details. So yeah, that's the talk. Thank you folks for listening, and any questions, let me know.
Are there any questions out in the audience?
Yeah, I have a question. Not a DevOps professional, but could you give a clarifying example of drift?
Yeah, so one example is, let's say there is a production issue or an environment has something going bad, and one of the engineers goes to your AWS console and makes a manual change because they want to fix something or they are trying something, and now that change is lost. So when you define something in your code and push it to Git, that's the desired state. An actual state is whatever is in your cloud provider or your Kubernetes. And if you want to detect that, that's what basically the drift is. Similar, like Kubernetes, what it does is it automatically remediates, like it reverts the changes and brings it back to desired state for your apps. That's what's missing in the whole environment, basically. Any other questions? Yeah.
How general or specific do the declarative statements for the environment get?
Would you mind just repeating that into the mic?
How general or specific do the declarative statements in the environment get?
Yeah, that's a very good question, and that is the challenge. I mean, so the example that you saw is basically what we do is we have types, component types, and if it's Terraform, we kind of provide a way to define, let's say, a Terraform module or variables or dependencies or whatever. If it's Helm, kind of similar where the Helm chart is. But we have also started facing that problem. So what we are thinking is kind of even breaking that and maybe say, here is your kind of settings file for your Terraform. And it'll have all the stuff that you need. For Helm charts, same thing. And then tomorrow, let's say, we have Pulumi that you want to support, or other tools that come up like AWS CDK or what have you. So yeah, it definitely is challenging. And that's why we want to keep it generic enough so that you can cover everything, but you also have a way to specify specific things that you need for those types. So yeah, for now, we started by everything in that YAML, for example, but eventually it might make sense to have separate files that are specific to those component types. Yeah. It's still kind of, like I said, it's early stages kind of in a way, but yeah. Anyone else? Awesome. Thank you, folks.
All right. How's everybody doing? Okay, more caffeine may be required. All right, so I have a pleasure of introducing Kavitha to the stage, chatting about evaluating your toolbox. So she'll be out here momentarily. Thank you. All right, folks, let's wake up a little bit. Please, round of applause. Thank you.
Thank you. That was really insightful, and I'll just set me up for this talk because to do environment as code, we need to do infrastructure as code first. And when Nader started talking, he said, hey folks, I assume you know what Terraform is, what Pulumi is, and we are going to go one level low, basic, to talk about infrastructure as code tools today. A little bit about me. Hi, I'm Kavitha. I'm an engineering manager in Microsoft. I lead a team of 6 engineers in commercial software engineering. Commercial software engineering is an engineering organization where we work directly with biggest companies and nonprofits to help solve their complex technical challenges with latest Azure cloud technologies. Personally, a little bit more about me. I live in New Jersey with my husband and 2 handsome boys. And in my spare time, I would love to build Legos with my kids. Agenda today, we are going to talk quickly about why use IAC and go through 4 different tools and some factors that I would consider to when you pick one tool over the other, and a quick demo of how we can deploy an Azure resource group using all 4 of these. I work in Azure in and out, so all my examples today are in Azure, but the concept is the same. Now, why use infrastructure as code? It's super easy to deploy resources manually in any cloud. In Azure, I can just go to the portal, create any resource in a few clicks. For example, I can have the full Kubernetes cluster up and running in no time. But what happens when I have to create multiple of these? Now I have to remember what exactly I did. I picked standard cluster, this version, and everything else, and that's just the first tab. And we have much more. And for the application these days, you have to create a lot more infrastructure. And that's where infrastructure as code comes in, where you can automate the entire stuff like others talked about. It's code, so you can put it in the repository, do the PR workflow, add validation, testing, and security scanning, everything in the pipeline, and automate it end to end and take it to the next level. And finally, it serves as an automatic documentation. If I have to look into what's in an environment, all I have to do is look at my code. Now, let's talk about our first tool, ARM template. ARM is how Azure deploys resources. Azure is built on top of ARM, which is Azure Resource Manager. It's super powerful. It's Azure's native construct. You get day 0 support with ARM, meaning the day a new Azure resource becomes available, you can deploy with ARM template. And it's written in JSON. Like all of us know, JSON is very machine friendly and not really human friendly. It's not very readable, maintainable, and it's hard to reuse. There is a concept of nested template and linked template. It's still really hard. That is an example of ARM template to deploy an Azure resource group. As you see, it's super hard to read. And there is something super cool I want to really quickly go over. If I have no idea what infrastructure as code is, I've always been creating resources manually on the portal. You can go to the portal, create any resource. In this case, I'm creating a resource group. And before I click create, I can click on download the template for automation. And that way you can get any resource in Azure, the JSON template, take it, modify it, and put it in a repository. Now to summarize, ARM template is written in JSON. It's not so easy to write. You can only use it on Azure, and there is still a large user community, and you get day 0 support. The next tool we are going to look at is Bicep. Bicep is nothing but syntactic sugarcoat sprinkled on top of ARM. Now, what I mean by syntactic sugarcoat is that under the hood, Bicep just uses ARM. It just gets converted into ARM template, use the same ARM APIs, and deploys resources. Bicep can be conceptually, it's like a wrapper on top of ARM template with much cleaner syntax, and Bicep can be converted into ARM as well as vice versa. Now, that's an example of the same Azure resource group code in Bicep. Like you see, it's much more concise, and compared to the ARM template, more modular, easy to read code compared to the ARM template. Now, we have a concept of Bicep modules, which makes it easier to write modularized code. In Bicep modules, you can write any Bicep code. Say, in this case, resources.bicep can be used in another file and reference it as a module. Now, let's take a pause and see why do we want to write modularized reusable code. One of our customers has a very strict security requirement where they have a, for example, set of corporate IP addresses, which needs to be whitelisted. So we were able to write that as a module, create a policy or a firewall rule, and use it in all other resources, like all the storage accounts need to be whitelisted. So with modules, we are able to create this magical compliance network with ease and maintainability. So the next thing we are going to see is there is a what if command option that's available in both ARM template as well as Bicep. If you had used Terraform, this is very similar to Terraform plan. This was only publicly available at the end of 2020. So what it provides us is, before we run or create or modify any infrastructure, if we run a what if command, it gives us exactly what it is going to modify. You can preview the changes before it applies. Now, to summarize, you get day 0 support with Bicep as well. It's much easier to write, reusable and maintainable. It's only available for Azure Cloud, and we had a small user community. They are growing now. If you haven't started writing any code, and if you're thinking about ARM template with Bicep, we highly recommend starting with the Bicep code. And there are a lot of our customers who have migrated from ARM template to Bicep and super happy with the simpler syntax. And the language is Bicep. Now, the third tool we are going to look up is Terraform. Terraform is built by HashiCorp. It uses its own language. Similar to Bicep, you get all the parameters, variables, and modules, and all the good stuff. This is the first tool today we are talking about for which can be used for multi-cloud. It supports all the major cloud providers. With Terraform, you can provision, apply, and destroy resources. We haven't seen a destroy in ARM template or Bicep. That's because it doesn't have one. We have a concept of a scope in terms of Bicep and ARM. If once we create those resources, you need to clean up the resource group or a subscription. But in terms of Terraform, we have a destroy command which lets us clean up the resources, cleanly clean up the resources. Now, that's an example for the same Azure resource group deployment in Terraform. Now, we said Terraform is multi-cloud. That doesn't mean that the same code that we write in Terraform for Azure can be used in AWS or any other cloud. The code is going to look entirely different. It only means that you can have a common language across all the clouds when we use Terraform. Now, we did talk quickly about Terraform plan when we went through the what if. So Terraform plan tells us exactly what the change is going to be applied. This case, in this example, there is one resource that's going to be added, which is the virtual network. Now, Terraform, when in case of ARM template or Bicep, how they compare the incoming code and find the change is they really look into the Azure cloud and find out what is there and do the comparison. But in terms of Terraform, Terraform maintains a state file to keep track of all the resources it provisioned. And it could be a local. There are two options with the state file. It could be local or remote. Local is going to be stored in the local computer. For remote, all the major cloud providers have their own, provide a lot of options. Now, state file is plain text file, and it might contain secrets. So we need to make sure it's stored securely, encrypted, and everything else. We're not going to go into the best practices. There are a lot of articles in each cloud how you can securely store the state file. But all we need to know to do the comparison is there is an additional administrative effort that's needed to make sure to store the state file. Now, the final checklist. Terraform doesn't used to provide a day 0 support, at least in terms of Azure. Now, We have an AZ API provider for Terraform. They have a link in the reference if you would like to check it out. This recently came out, so we do have a day 0 support with Terraform now. I'm not sure about other cloud providers. It's super easy to write. There is an additional state file administration that you want to think about. It is multi-cloud, and there is a huge community of users, and the language is HCL. Now, the fourth tool that we are going to quickly talk about is Pulumi. If Terraform is the most popular kid on the block in IAC world, Pulumi is the new cool kid that's coming up in IAC world. Pulumi is also multi-cloud. On top of supporting all the cloud providers, it can also manage users in Postgres SQL, MySQL, as well as namespaces in containers like Kubernetes. The super cool thing about Pulumi, though, is you can write it in all these full-fledged programming languages like C#, Python, TypeScript, JavaScript, and Go. What gives us that you can use your favorite IDE. If the application developers are already using these languages, it's super easy for them to start writing IAC code. It also gives us an unified agile development process if it can follow the same process as your application code. And in terms of testing and validation, we saw how the ephemeral environment works. You can tear up and tear down. In those cases, you can use your unit tests, functional tests, and integration tests all in the same way that you write for application code, since it's a full-fledged programming language. Bicep doesn't have like a great testing framework yet, and Terraform can probably write integration tests with TerraTest and other tools. But with Pulumi, you can do code validation and testing just like your application. And Pulumi also provisions, updates, and destroys infrastructure, very similar to Terraform. It also uses a state file to track all those resources that it provisions. But this case, this state file is encrypted at rest as well as in transit. So they have a more robust state file management in terms of Pulumi, which automatically comes with the tool. And for the password, they support all major cloud providers like Azure Key Vault, AWS KMS. So it has more additional support that we thought through this before. Now, that's a sample C# Pulumi code. Like I said, you can write this in TypeScript, Go, or any other language. And similar to Terraform, this code is going to look entirely different if you're writing for other clouds. And for example, this Azure resource group, if you see the way it's written, it's just creating an object for this class. And that's super simple. Of course, you can add more parameters, but for an application developer who has never written an IAC code, I think this is super easy for them to start working with. And the final checklist, you don't get D0 support with Pulumi because somebody need to write the underlying providers, how it interacts with the clouds. It's very easy to write. If your developers are working with those languages, it's easy for them. There is also a state file in case of Pulumi, and it is multi-cloud, as well as you can maintain Kubernetes and users in MySQL. There is a small community right now, but it's gaining popularity as we speak, and all those are the languages that you can write Pulumi code with. Now, let's take about some of the factors now that we have seen all 4 tools. How do you decide one tool over the other? Now, if we need any open source tooling, like linting, compliance check, security scanning, and testing, the tool like Terraform has more of open source tools to help, like TerraTest for testing, TF-lint for linting, and security scanning and everything else. So Bicep may not be a great place to start with. And if you need day zero support, you're using latest preview GA products with your cloud providers, then you might want to look at something that's cloud native rather than Terraform or Pulumi. The third thing is, like, if you have an existing standard in the company that the rest of the company is using ARM template, or you have an existing skill set that I've never started IAC, but my application engineers already know TypeScript. That's something I want to think about. And the next one is, do we really want to have that administrative overhead of state file? If it's a big deal, then probably not, Terraform may not be a great choice. And do you need to deploy to on-prem, cloud, and hybrid environment? Do I have a multi-cloud? Do I want to use a common language across all those? How do my DevOps work? How do I want to put this in CI/CD? All those things we would like to consider. And if I have a multi-cloud environment, I want to use the same language. Definitely, Bicep is not going to work. Now, finally, am I starting with greenfield or brownfield? If it is, if I have an existing infrastructure already and I want to script it out, at least for Azure, we have like a couple of options. We have a AZ group export where you can point to a resource group and you get an ARM template. You can convert that to Bicep, of course. Or if you're using Terraform in Azure, there is an open source tool that some of my colleagues wrote. It is in the reference call. It's called AZ Terrafy, where you can point to a resource group and you get the Terraform configuration file. Terraform does have an import, but you need to still manually write the configuration style, so configuration file. So they came up with this open source tool. I'm sure the other cloud providers will have some open source if you already have an existing infrastructure and you would like to move to infrastructure as code. Now with that, I'm going to quickly go over a little bit of code as well as a recorded demo in the interest of time. Give me a, can you help?
Just one moment.
Sure.
Headphone port? I don't know where your headphone port is.
No, I don't need audio. I just need this on the screen.
Oh, you need.
Okay, cool. Thank you. All right, we can quickly go over some code and do a quick demo before I wrap up. So that's my simple ARM template for deploying a resource group as well as a storage account. We have 3 parameters here, resource group name and storage account. And here is how the lengthy the code is. And we also have something called depends on here because we want the resource group to be created first before we create the storage account. And to compare that with our Bicep modules, this code is like, it starts with the subscription scope. It creates the resource group here. And then this one is for the storage account. And the code is super modular. It's calling a module called storage Bicep. And the depends on, if you see here, compared to the ARM template, is much more readable and simple. And that's our quick storage account code. Again, compared to ARM template in a single huge file, this is a much modular code. And let's quickly look at Terraform, how it would look like. It's very similar to Bicep. It's going to use an Azure ARM resource provider, and that's our resource group code and the storage account code. And if we have to look at the same code in Pulumi, like we talked about, these are all written in classes, and you're just creating an object for both the resource group as well as the storage account. Excuse me. I need my Windows Media Player.
Windows Media Player?
Yeah. But it's not going
So we'll have to exit full screen. And you should be able to go into it.
to. Okay. All right, thank you.
Yep.
Thank you. Sorry about that. So we are going to quickly talk about how an ARM template and bicep, they both can be deployed using the same AZ CLI commands. Here we have AZ deployment. I'm using a confirm, which is similar to the what if command we talked about, and the same ARM template we saw. And that's taking a few few seconds. And it gave me an option, like gave me exactly what it is going to deploy, which is a resource group as well as a storage account, and it's asking for a confirmation. And it already created those two resources. One is the resource group, one is the storage account. And in terms of Terraform, we use the Terraform init to get all the providers up. And then the Terraform plan, similarly we talked about. And again, it's going to ask, it's going to give me the details of what it is going to create. And to apply the changes, I have Terraform apply, which is going to ask for confirmation again for those two things it's creating. And once it's giving me a nice little update of, here I'm creating this is the percentage, and then it's done right now. So my storage account as well as resource group is up, and it's nice and easy to clean up. All I have to do is Terraform destroy to clean up those two resource groups, those two resources. So it has two resources that it's going to destroy. It's telling me exactly what it's doing, and it's done. And in terms of Pulumi, similar to Terraform, we have the Pulumi preview. When I got into Pulumi preview, it's giving me three different options of environment. Here you can create any environment, and then for the state file passcode, I am using local, so I gave a passcode to encrypt this particular state file. So in terms of Terraform, you can also write into different environments, but Pulumi gives an very nice option to add it right here with what environment. If for different environments, it uses different state file as well as different passcode. So now I have the passcode, and then similar to Terraform plan and the what if command, it's going to give me the changes it's going to do before it applies. There are three things it's creating. One is the stack itself, one is the resource group, one is the storage account. And to make it work, similar to apply, I have Pulumi up, and it's asking for the environment again and the passcode, and now it's giving me a clean, here is the two things I'm going to do, and it's done. And finally, we have for cleaning up the resources, we have Pulumi destroy, which we saw. And one nice thing about Pulumi is that when you see the resource group here, it is created when I wrote the code, I only said yes, name the storage account as SA. But when it created the storage account, it added a random value and created created the storage account, which is super cool, which needs additional work in Terraform or something else where you need to create your own random variable. But Pulumi has an option of if by default it adds a random value on top of the name of the resource. And that's all we have today. Any questions? Yes.
Oh, just wait for the mic 1 second.
Hello. Yeah, I guess I'm not from Pulumi. I'm not the authoritative source, but I believe they have an Azure native package which provides 0-day support. So I'm not sure if you knew that, but the question is, meaning I know Microsoft has done great work with Power Automate for low-code for business applications. What is your point of view for infrastructure automation with low-code?
With which one?
With infrastructure automation, are there any low-code tools in the market?
No, I'm not sure. I'll have to get back to you.
Do you have, what's your point of view? Is low-code the next big thing or the next cool kid on the block? Or?
With the low code, even with Power Automate, I think we target more for folks like engineers. It's not generally for engineers, right? We want to quickly put together something as well as on a POC, as well as for someone who is not have a full-fledged engineering team, they can bring any app live. But with the IAC, I'm not familiar with the low-code tools yet, but I believe full-fledged IAC code would be for the application engineers and the infrastructure engineers, and the low-key code, in my opinion, would serve someone who is coming up, someone who really wants to put together something faster. With all the environment as code and policy as code and everything as code, when we automate, these are getting really complex infrastructure. And I don't know how far we can get those with the low-code tools. Of course, there will be low-code tools, but then the target audience, I believe, would be different. Similar to Power Platforms. Any other questions? Thank you.
All right. We are about to head right into lunch. So if folks can take their humans into that direction in the cyclorama, lunch will be served shortly. Thank you very much.
All right. Hello and welcome back. I hope you all enjoyed lunch, got some food, got to make a new friend or two. Next up, we have a talk by Thomas Stringer, a principal software engineer lead at Microsoft, on reducing your Kubernetes attack surface. I know that's so critical to a lot of our enterprises, so I'm really excited for this one. I know we have the running joke on Boston DevOps of hashtag don't use Kubernetes, but I'm really excited to use Kubernetes. So on that note, give it up for Thomas Stringer.
Thank you so much for the introduction, and thanks for having me. So for the next 35 minutes, I will be discussing zero to secure using Open Service Mesh to easily reduce your Kubernetes attack surface. Before we get into the zeros and the ones, just a couple of quick notes about myself. My name is Thomas Stringer. I am a principal software engineer lead at Microsoft. The project that I'm currently working on is Open Service Mesh, which unsurprisingly I will be talking about here today. And some of the things that I've worked on in the past recently, I was a developer working on Azure Linux software, DevOps tooling in the cloud and not in the cloud, open source tooling. On a couple of personal notes, I'm fairly local here. I came down from New Hampshire, coastal New Hampshire, and whenever I'm not behind a computer, I'm oftentimes found surfing in our frigid northern New England waters, snowboarding up in the mountains, or I am a classically trained pianist since I was about 6 years old. So let's get right into it. Why is service mesh? But before we talk about service meshes, I think it's really important that we take a step back. Kubernetes is very prevalent in our digital world. Many of us, I'm sure sitting in this room, have Kubernetes as a large part of our daily operations, or at least daily thoughts, right? And this is not because Kubernetes is cool and just a personal passion project. The data is out there. Kubernetes is everywhere. And the growth is exponential. And the reason behind this is, as a platform, Kubernetes really unlocks a ton of capabilities, and it makes our lives as administrators, software developers, IT personnel, much better, or at the very least, much more interesting. And with this platform and all of these capabilities, we inherit a level of complexity. And oftentimes with complexity, what we get along with that is a challenging environment to navigate. And one of the things that is extremely challenging, but also extremely important, which we're going to be focusing on here today, is security. Security is something that can make or break organizations. We all see it all the time. We hop on social media or on the news, and we're not surprised on a daily, weekly basis. Data breaches, bad actors, environments being compromised. And I wish I could say that we live in a world where security was easy and really good by default. Or better yet, I wish I could say that we lived in a world where there were no bad actors or people or software with malicious intent. But that's not the reality. We find ourselves in a place where this stuff is hard. Security is difficult, security is challenging. There's people that have dedicated their entire lives and their entire careers to information and digital security. And then there's the rest of us. And we are expected to understand it at a certain level, but we're really expected to make sure we're implementing this in our environments. And in the context of what we're talking about here today, our Kubernetes clusters. Because we're Kubernetes cluster operators and administrators, and we might not be those security experts. This is difficult stuff. X509 certificates, public key cryptography, PKI, TLS. And then we have application developers who are writing the software that we're running in our Kubernetes clusters, and oftentimes they're in the same boat. They might be experts of their domain, of their programming languages, but they might not be security experts, or they might not even care so much about the infrastructure and the networking between those applications. Here's the thing, though. Oftentimes with security, it's one of those things where we just keep punting it to the next phase or the next sprint, or we'll figure that out later. But that's a problem. That's a problem in our mindset, and that's a problem in the way we approach software development and software delivery. Because when we don't consider security proactively, then we're having to consider it reactively. Then our environments are on the front page of the news. Then our company has to notify users of a data breach. And this is not a situation that anybody wants to find themselves in. Not me, and I'm sure not you. And that's the problem. We have this perfect storm of a very complex but powerful platform in Kubernetes. We have security, which is extremely difficult, but it's not something that we can push to a later date. None of us in here can afford the cost of not doing security right. So let's see how a service mesh can help with that in our Kubernetes clusters. The first security principle that I'm going to be discussing here today is defense in depth. And I'm going to start this out by saying if there's one thing, and only one thing, that everybody in this room walks away with, I will personally, as the speaker, I will be satisfied. And that is to change our mindset from if our environments are compromised to when our environments and our Kubernetes clusters are compromised. See, because we have this human nature about us where we say to ourselves, this iPhone in my pocket, nobody cares about, I'm nobody. Nobody wants my data. Nobody wants to be in my digital world. Nobody cares. Or maybe my company, we're so small, nobody even knows anything about us. No bad actors are trying to get to us. And that's just not true. The few times that we have data about how many times bad actors try to infiltrate our environments, whether personal or organizational or professional, it's scary stuff. So I think one of the biggest takeaways here is when you go from saying if something gets into my Kubernetes cluster to when something gets into my Kubernetes cluster, it triggers a reaction that makes you figure all of this out proactively. And thankfully, we have tools out there such as service meshes that can help us solve a lot of these problems, or at least some of them, fairly easy. And the other really important thing is we have to have an answer for this, because as the IT professionals, whether we're operators, admins, software developers, DevOps engineers, cloud engineers, whatever you are, we're going to be the ones getting the phone calls. Hey, bad news. Turns out we found some traces of bad actors in the clusters. What's the problem here? What could have happened? And then we're sitting there wondering what could have happened. And that's where a service mesh can really help add security. And defense in depth is really about maximizing your strength for your surface attack area. And the thing that I think is really interesting is a lot of times when we visualize our surface attack area, we picture ourselves or our clusters or our computers or our environments in this big bubble around them. But let's try to shift that visualization from a bubble, a single-dimensional bubble, to more of what I like to consider a surface attack onion. Okay, this is all about multiple layers, especially when we start adding platforms that have a high layer of complexity, such as Kubernetes. There's a lot of layers here, right? And here's the problem with that surface attack area onion. Everybody knows about and cares about those outermost onion layers. I mean, we're talking about the obvious things of, hey, Kubernetes cluster, is there public access to to that cluster? Can you get to that Kubernetes cluster from the internet? Oh, wow. We got to make sure that's not, everybody's going to, all hands on deck, make sure nobody can access that Kubernetes cluster from the public. And then you're going to go to the layer a little bit deeper. Okay, well now who can actually access that? Let's only make sure, the certain engineers and the certain administrators can access that. And the problem is when you keep going deeper and deeper in those onion layers, people care a little bit less because it's harder to picture some of these issues that can arise. And then all of a sudden you start to get into that deep layer inside your Kubernetes cluster, an interpod communication. And we all say, it's in a Kubernetes cluster. Like nobody's gonna, we don't need to worry about that network traffic within the cluster. We picture this big wall around our cluster, and it's just simply not the case. So I am going to approach this with a little bit of storytelling here, okay? So these are what our assumptions are. We have our Kubernetes cluster, and we have our software running inside our Kubernetes cluster, application pods talking to each other, and we assume that bad actors are just bouncing off of this security wall for our clusters. That's our assumptions. But if we start to shift that mindset from if to when, now we're going to start picturing something like this. Some of those bad actors are going to be bouncing off of this Kubernetes security wall, but some of them are going to gain access inside our Kubernetes cluster. And that's a scary thought, but that's a very real thought, and that's a very real situation here. Or worse, those bad actors, they get access inside of our Kubernetes cluster. What are they doing? It's really common for these bad actors to operate under a monster in the middle attack. Basically sniffing network traffic, likely phoning home with it. So now we find ourselves in a position where we assumed that no bad actors would ever get into our Kubernetes cluster, so we're sending data across the wire between our application pods in plain text, and then we get the phone call. And we find out that there's a good chance that these bad actors have been sniffing our network traffic. So let's talk about another scenario here, and something that's also very real and on the minds of a lot of people, especially recently, is supply chain, right? What you see on the screen here on the left is a really common thing that we all deal with in the Kubernetes world, right? So we work in pods, right? The base compute unit of Kubernetes. And what we know that what makes up a Kubernetes pod is one or more containers. And part of the container definition in the manifest is to tell Kubernetes, hey, I want to use this particular container image for this application pod. So what you see up on the screen is likely, for those of us that work in the Kubernetes world, that's likely a very common thing to see. Maybe you want to deploy some software into your Kubernetes cluster that you did not write, or that your company didn't write, or people that you know and maybe trust didn't write. But you want to run that software in your Kubernetes cluster, so you refer to it, in this case, my favorite app. And my favorite app is perhaps hosted in a container registry that you don't own. Maybe it's Docker Hub, maybe it's GitHub Container Registry. But it's something that you don't own. You don't own the delivery lifecycle of that container image to that container registry. This is a very typical scenario. But focus your attention on the tag that you see up there, latest, right? I think without a shadow of a doubt, this is the most common thing you would see all over blog posts, demos, documentation. It's the easy, normal thing to refer to a container image. And latest is typically a sliding window tag for a particular image. And usually that's not a big deal, right? So in this example here, you have my favorite app, and The developers pushed out v1.0.0, so latest picked that up. Great. Everybody's happy. They pushed out v1.0.1. I know nothing about the versioning of my favorite app, but all I want is the latest and the greatest of this application. So I pick up that version. And then I pick up v1.0.2. That's great. I know nothing about the versioning. I pull that into my Kubernetes cluster. And that is what you need to really realize, is that you're pulling those images into your Kubernetes clusters. You're pulling in software that you likely have not validated, at the very least, not the code diff between those versions. And you've opened up your front door of your Kubernetes cluster to software that you probably don't know a ton about. And what happens when a bad actor, somebody with malicious intent, somebody that gains access to that container registry or already has access to that container registry, pushes out malicious code into an updated container image? I've called that version V bad, but it's very unlikely that in the real world it will be tagged so appropriately. But that's what's going to happen. And then your Kubernetes cluster is going to pull that in. And now that code that you said would never possibly get into your cluster is going to be running in your cluster and doing who knows what. And that's really scary. And that is a specific situation, but not an uncommon one. Because with the growth of Kubernetes and the demand for standing up environments, for operators and administrators, and for software developers to be pushed onto Kubernetes without having this background and the experience and knowledge and training to know the right way to do it and the wrong way to do it, it puts us in these situations that we definitely don't want to find ourselves in. So how does a service mesh help us here? And for this particular scenario with defense in depth, one of the biggest things that a service mesh can bring to you, such as Open Service Mesh, is MTLS. And MTLS stands for Mutual TLS, or Transport Layer Security. And TLS is something we live in this world, whether we know it or not. When you go to a website, HTTPS, you are utilizing TLS at some level to encrypt network traffic. And what this typically looks like on the public internet is usually one-way TLS, okay? So what that means is, let's say I'm going on my bank's website. I really care if that is really my bank. So I am the client and I'm doing authentication to make sure I'm sending all of my credentials and sensitive information to actually my bank and not some impersonator. And that's typically what you would see in the public internet. My bank doesn't really care about who I am. I mean, it does, but it's not going to use TLS to authenticate me as the user of the bank. But when we have these isolated environments like Kubernetes clusters, it's common to want to utilize this two-way authentication with TLS to make sure the client and the server both authenticate each other before they start sending encrypted network traffic between them. This is a really common scenario with private environments where you would oftentimes also find a private certificate authority that might not be known to one of the publicly registered certificate authorities. So this technology and this idea of MTLS, it provides us with this encrypted network communication within our Kubernetes cluster. And the really cool thing with Open Service Mesh and many of the other leading service meshes is it gives you that MTLS right out of the box. And we're going to see what that looks like. So without MTLS, the network traffic going between your application pods is likely going to be unencrypted, or it's up to the application developers to ensure that is encrypted. But here's a challenge when we start to push that responsibility onto the applications and the application developers. It's highly complicated. And then we run into issues such as certificate issuance and certificate rotation. And I really love this point because certificates and expiring certificates is one of the few things that we don't have to touch or change, and we'll still get woken up at 3 a.m. with an outage. Right? And it's not just us, right? We see very large platforms running into these issues, and it's not an easy problem to solve. It might be easy on paper, but it is definitely not easy in practice. So now we can add a service mesh into our Kubernetes cluster, and the way Open Service Mesh handles encrypting this network traffic is it does a really interesting thing. It injects a sidecar container into your pods that are participating in the service mesh. And the way it does that is it patches your resources when they're created by using a webhook. So the proxy, the sidecar container that OSM and many other service meshes use is what's called Envoy. And Envoy is actually also another really great CNCF project, very powerful, worth looking into. And what we do is we inject the Envoy proxy sidecar, and then we do some work with IP tables to make sure all of the network communication for that pod is going through that Envoy proxy. Then at this point, it's up to Envoy to encrypt, and then on the other side, terminate TLS. And the really cool thing about this is this helps us to ensure that all traffic going between pods that are participating in the service mesh are encrypted. And the other really cool thing is it's entirely transparent to your application that's running in those pods. So let's take a step back a little bit, because there's a very common argument out there like, hey, I don't want to add service mesh. Like, I'm just like, we're application developers. We need to know what HTTPS is. We need to understand this. This is our responsibility. I would argue that's not really a great approach. And the reason behind that is Kubernetes allows us to not have to worry about so many things, right? That's the whole point of using Kubernetes. Because I'm sure we all remember the days before Kubernetes or distributed computing, and we needed to figure out lots of really hard challenges like scaling and stuff. Like, hey, I'm the application developer, and I have to worry about what happens when the VM dies, and I need to make sure something else is stood up. Kubernetes has made that we don't even, it's there, it's part of the platform. So we defer a lot of software hosting responsibilities to Kubernetes. Why stop there? Security is a significant thing that if we can defer to Kubernetes, which I like to consider a service mesh and extension on Kubernetes, we should absolutely do it. And the second point there is, I've said this so many times, but it's really important to internalize. Security is hard. And to expect 100% of the application developers and 100% of the software to do it correctly 100% of the time is just not the case. So being able to centralize this solution is really important. And then the last point is another one that a lot of people don't really think about until bad things happen. You get the phone call, hey, bad actors got into our Kubernetes cluster. Okay, I think the application developers are using network encryption and terminating TLS and doing what they should be doing. Okay, how do we know? Auditing becomes a huge challenge when you put it in the responsibility of multiple different software teams. In a good case, auditing is hard, but in the likely case, it's simply impossible. So I've talked about some really cool stuff with MTLS, and you must be sitting in your seat saying, this has to be so complicated to set up, right? We're passing the complexity requirement from one thing to another thing. This must be difficult. But that's the thing. It's not with Open Service Mesh and many other service meshes. With OSM, 2 simple commands, and MTLS is transparently there. OSM install, and then you add your namespace to the service mesh. And that's it. From that point on, OSM is going to be injecting those Envoy sidecars and making sure that traffic is transparently encrypted across the network. So I would like to show just a quick demo, and this demo is basically showing what I was talking about with the bad actor. So just to paint the picture a little bit, we have, is that not showing? Okay, give me 1 second. Good. So this small, simple application that I've created, it's just 2 pods, okay, 2 application pods. The first one is a client, as you can see on the top, and all that client is doing is running curl every 2 seconds. And then the second pod is a server pod, which originally was only supposed to be running Nginx and just serving the default Nginx page, right? Welcome to Nginx, everything's working, great. But I have put in a bad actor with a second container within this server pod. And this bad actor, this is not some custom malicious code. This is TCP dump, a tool that many of us have used and are familiar with. So all this bad actor is doing is just dumping out network traffic going between, or really going to the server pod, to and from. And then I have a service down at the bottom there so that the client can talk to the server pod. So let's see what that looks like. Let's see. So if we look at the logs of our bad actor, so all I did there was just dump out the logs of the TCP dump container. You see a lot of TCP dump output, but you see something really interesting there. You see the network traffic in plain text. In my case, this is a demo of showing this. So all you're seeing here is welcome to Nginx HTML, but in the real world, this is sensitive information. This is user data. This is secrets, private information, all in plain text, just with TCP dump. And this thing could be phoning home, pumping this data outside of the cluster. Pretty scary stuff. So what we can do is we can install OSM. So you can see there what happens first, and this is going to take a couple of seconds. We run OSM install, and that is going to install the bits for the service mesh into the cluster. And that includes primarily a control plane. So OSM is divided up in what we consider the control plane, which is what configures all of the Envoy proxies. And then we talk about the data plane, which is the mesh of Envoy proxies that are talking to each other. So in the next few seconds, OSM should be installed. And then what we're going to do after OSM is installed, okay, you can see it there. So OSM was installed successfully in the default namespace of OSM system. And then the second command there I ran, like I discussed before, was I added the default namespace to the service mesh. And once I did that, I had to recycle the pods so that the Envoy proxy could be injected into those application pods. And I'm just going to wait a couple more seconds for those pods to come up. Now, something I didn't show before was originally the client had a single container, right? It was curl. It was just curl. The server had the Nginx container, but also the bad actor container, the TCP dump container, so that had 2 containers. You can see right there with the container count, now the client has Envoy as a second container that was automatically injected. I didn't do that. That was automatically injected. The server has Envoy proxy, which is also automatically injected. So it looks like they are up and running now. So I want to see the logs of what that bad actor can see now. And if I scroll down, you can see that we no longer see that plain text, welcome to Nginx. It's encrypted. I didn't do anything. I just installed OSM. And now, when that bad actor gets into our Kubernetes cluster, I mean, it can't see anything, right? So I discussed almost entirely about defense in depth because I really believe that this is one of those things where it's the saying, it's very low-hanging fruit, right? You just add it to your cluster, and it just works. The next one I'm going to talk about, I am running low on time here, a couple more minutes, really quickly, is another security principle that a service mesh like OSM can help with, and that's the principle of least privilege. And the principle of least privilege states that everything should only be able to do what it needs to do. And like, we're really used to this, right? If my admin gives me access to that Linux application server, they're not going to give me root privileges, right? All I need to do is maybe create a file in a directory. So they're not going to give me root privileges. They're just going to give me the ability to create files in that directory. And principle of least privilege says we should be doing this entirely, including within our Kubernetes clusters. So if you look on the left graph there, that's what it looks like by default. Maybe I have service 1 and 3 that are supposed to be talking to each other. I expect that. Like, these are the applications doing what these applications should be doing. I have service 2 there. Maybe it's not malicious. Maybe it is malicious. But the point is, it has nothing to do with service 3. But by default, it can talk to service 3. So now if service 2 is a bad actor or has malicious intent, it can access it. And I'm not saying it's going to get anything. Maybe things are encrypted. Maybe it's not. Principle of least privilege says service 2 shouldn't have access to that because it doesn't need to have access to that. And the way OSM handles that is you create what's called HTTP route group, and you basically define this at a layer 7 level to say, hey, here's the different paths. You can use path regular expressions, headers, HTTP verbs to define the targets. And then you define the traffic target, which says, okay, here's the destination, and here's the particular rules that I just defined that this applies to. And then the sources are what can access these destinations. So this forces me to be explicit because it's denied by default otherwise. This is really powerful stuff to make sure that we are exercising principle of least privilege. So over the course of this session, hopefully we all can agree that security is very difficult. It's a very big challenge. And with all of the great stuff that Kubernetes gives us and all of the scenarios that it unlocks, it's no different than everything else that we build software on top of. It has a layer of complexity, and it has its own surface attack area. And if we change our mindset from if to when there's a bad actor in our Kubernetes cluster, it'll allow us to be more proactive with it and start considering things like service meshes. And service meshes like Open Service Mesh can make this stuff a lot easier and really transparent to applications. I did add the and more there because I think it's really important to explain that service meshes such as Open Service Mesh are not just for security. There's some really cool other features with complex traffic routing that service meshes can really unlock. But I think the thing that we all need is an additional layer of security. Thank you very much for your time. I will be around after. If anybody has any questions, I'm going to be hanging out outside of the door, or if you want to chat about anything here. And I appreciate your time, and I hope you enjoy the rest of the conference.
Thank you very much. All right, so up next we have our long-awaited open spaces again today. Aaron's done a fantastic job organizing, and we really appreciate all the work they've done for us for open spaces. And so give a hand for Aaron.
a microphone. Now everyone can hear me. Yeah, open spaces. Who was here yesterday? Almost everybody. That's pretty good. Was anyone not here and doesn't know what open spaces are? That's actually pretty good. I think everyone's heard of it now. So we're all excited about open spaces then? That's all right. A good half dozen people care about open spaces. That's good. We can have at least one get together. It'll be wonderful. So we know what it is. So here's where we get to turn over the conference to you all and get to suggest the topics of you want to talk about. We'll break into the same groups and do kind of a similar thing as before. So again, if you've had a question from a talk that you want to discuss further or an idea that came up and you're like, I wonder if anyone else has ever thought of that. Those are all great ideas for open spaces. I think we're going to do a similar process. So if you want to come over to this side down front, we will have you write it down on a Post-it note and suggest your topic for an open space and kind of give the little 30-second, 2-sentence pitch to the crowd of why you want to talk about that. And then we'll kind of roll through. I think we had a couple left over from yesterday. Did we save those two, or did they get lost in the void? Motivation, and then we forgot. So if someone remembers one of those and wanted to talk about it, this is a great time to also pitch that.
That was it.
Something cloud formation?
Anything cloud formation, not Terraform. We do still have them. Yeah. So why don't we put these two back on the board so we can put them back into rotation? All right, here we go.
Cool. So while you're thinking of that and make your way over this way, just a quick reminder of open spaces operate according to 4 principles and 1 law. That was whoever comes is the right people. So whoever you've got is perfect. Whatever happens, happens. The only thing that could have happened, we don't have to worry about the outcome or what's going to happen. It'll all work out. We'll be surprised or we won't. And maybe that's what's surprising, is that it happened exactly as we expected. Whenever it starts is the right time. We'll try to stick vaguely to a schedule. And whenever it's over, it's over. So you don't have to draw out to the full length of time. You're welcome to kind of conclude and move on and do something else. And remember the law of mobility. So if you're not providing anything to a conversation, you're not really getting anything out of it, you're under no obligation to stay there. You can use your mobility to move on to a different open space and have another discussion that might be more fulfilling to you this afternoon. And I think we've got fewer people here than we've had previously, so you know what? If we don't have to go through our full 3 things either. If we've only got a couple things, maybe we'll wrap everything up a little bit early as well. So yeah, do we have some open space ideas?
Someone's ready.
Yeah. Oh, and for everyone virtually, I believe Cody is running the sort of lean coffee style open spaces on the Discord. So look to there for more instructions from Cody about what's going on, and participate online as well. They'll just be a little bit different spaces. So, yeah. Sorry, go ahead.
Right on. Hi, my name is Grant. I have 2 open space proposals. The first one is cool tools for your toolbox. If there is a cool tool that you think that the world should know about, come share it. If you would like to know about cool tools, come learn about them. The second is my friends and I have a printed edition of DevOps Against Humanity. If you've ever played Apples to Apples or Cards Against Humanity, you already know the rules. So let's play DevOps Against Humanity.
I love it.
And I forgot to mention, just like last time, we have 2021 hoodies. So for proposing, you get your own 2021 hoodie.
Or a second one.
Or a third one.
What size? XL? Last one. Thank you so much.
We are out of XLs, by the way. I see you raising your hand. Just come on down. We got plenty of time.
Yeah.
Looking for how different individuals and folks solicit feedback when they have technical solutions or ideas or tools that they want to use across the team or the organization. How do you go about sort of getting validation or ideas for improvement about that within your team or your organization?
Awesome. Soliciting feedback about tools across the organization.
So we keep hearing that DevOps is not a title and it's not a position, it's a culture. So how do you start that shift within your organization?
This may not be relevant, but deployment of data across environments. We talked about the code deployment, but our biggest challenge is seeding the different environments with different data. Well,
I think that is relevant.
Oh, yeah.
You know, that's kind of one of the beauty of open spaces is there is no such thing as an irrelevant open space. Like at Austin, we actually talked about home labs and compensation and things that were totally orthogonal to the conference. So definitely.
Training, mentoring, growing sort of junior engineers.
Was it training and mentoring junior engineers? Yeah, awesome.
So is a 10x developer a mythical creature?
Good, thanks.
Okay.
So is a 10x developer real?
Yeah, is 10x developer real or is a mythical creature? Okay.
What size would you like?
Medium?
Yeah, you got it.
Did Bruce say they're going to come by?
Yes, they're already here.
Right. We do have one sponsor who is on their way because they wanted to submit a breakout.
All right.
So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have room for 3 more.
Nice.
If anyone would like to submit. And keep in mind, if we get more than 12, we will vote. If we get less than 12, we will have empty spaces. And that's not fun for anyone. But in that case, I'm going to propose one.
Yes.
Probably one of the most fun breakouts I've been to in a long time. Home labs. Tell me about your home lab. What do you do with it? What is it running? What have you learned from it? And what have you brought to your day job with it?
Out there, can you make sure they get to the Wimberley like right now?
So professional developments or certifications.
Professional developments or certifications?
Yeah, I'm open to talking
Slash.
about it. There's a slash in there.
Hey, can you make sure that the person from Bruce who wanted to propose an open space gets here right now, or just tell me what the topic is?
Or just tell us over the radio.
Okay.
Yeah.
Never mind, we have them here.
Yeah, that's what I'm saying. Okay. Well, I've got one. Ephemeral environments. How to do that. It's tough.
Anyone else?
Good. I think we have enough.
We have exactly 12.
Wonderful.
Anyone else? Speak now, forever hold your peace.
I'm giving it one awkward silence's worth. Oh, see?
Oh, there we go.
See? Yeah, announce it first and then write it down.
Get branching and merging strategies.
Get branching and merging strategies. All right. I think we're good after this one to probably arrange the schedule. So I would say this will take a minute or two. If you care deeply about sessions not happening at the same time or in a particular room, feel free to come down and participate in the schedule creation right over in the corner with Don. And in a minute or two, I think we'll have a lineup for you for the first round of open spaces.
Well, we have 13 now, so let's, I actually think we might do the same thing that we did yesterday, just show of hands who would like to do each one.
All right.
We can at least eliminate one that way.
Sure.
All right. Anything CloudFormation, not Terraform. Wow, nobody.
No, nobody wants to talk about CloudFormation. I'm sorry.
Right.
I didn't live either day.
All right, good. So we've got 12. Sorry if you're the one that proposed to talk about CloudFormation. You can have your own open space anywhere, which is actually true. Sometimes you have an open space and you're the only one that shows up. But then how often do you ever get to actually dive into those topics you really want to think deeply about? So it is a pretty good opportunity to sit there and think about it and I don't know, maybe write some things down and do a little deep thought exercise. But we'll see where it goes. Whoever shows up is the right people, and sometimes it's one person. So we'll throw the schedule together, and then we'll. I should have I need royalty-free music just for moments like this.
Put the Jeopardy theme on.
Phenomena. Was there another? What about it? Where's it going? Oh, I'm moving it.
I'm actually going to put you at the end of the day because that's very engaging.
We can also play DevOps Against Humanity at one of the tables. Would that make more sense to do it in the cyclorama at one of the tables?
Your discretion. I mean, we've got 12. I think it would be a good fit for Martin Hall.
All right, Martin Hall works. It's good. If you haven't played DevOps Against Humanity, it is a good time. It is all the joys of Apples to Apples or Cards Against Humanity, where you're doing the word association games, but it's all DevOps terms. Sometimes it hits real close. Do we have a first?
Unfortunately, I have to look up our schedule because I don't remember it.
Oh, I don't need the time. I just need the first round. I guess we should know the times when they're going to start. Oh, no. I hit the button because I was like, oh, I'll look it up, but then I'm the one sharing the thing on the screen.